Hello again, it is Mr. Ensminger, and I am here today with the next asynchronous lesson. You've been learning about variables and print and input, and now a little bit of math. We're going to expand your math knowledge. We're going to show you some of the math commands that are in Python. As you may remember, may or may not, from one of the early lessons, the first week of school, second week of school, somewhere in there, we asked you to do the exploration of turtle. The turtle video showed you how to make different shapes. And at the top of the program in that video, there was a command that said import. The import command lets you pull in other libraries from Python that aren't built in, things that you're not going to use every day. Like you're not going to do all turtle stuff like little hexagons in every single program you're making. Well, you're not going to use sine, cosine, tangent. You're not going to use square root in every single program. So rather than putting it as part of the core language, they have it as what's called an import file, an import library. So at the top of our programs, if we ever want to pull something in, we're going to say from, and then in this case, we're going to say math. And I'm going to import an asterisk. So again, at the top of some of your programs, you will have import statements, which pull in libraries of commands not built into Python. Okay, so let me interpret this for you. You see from and import are in orange. They're keywords, recognized words. Math is it's a library, just like turtle. There are other ones that are in there. The asterisk is a character that doesn't mean times in this case. It means a wild card. It means everything. It's a throwback to old computer times, DOS, and if you have ever heard of Linux. The wildcard character, the asterisk, means everything. So basically what you're saying there is, from the math library, import everything. Like not just sine, not just cosine, but everything. And that's pretty much how you're going to always do that. There's very rarely a time where you're going to say like, oh, I want this whole library of commands, but like I only want one. No, just like give me all of them. It's not really that big a deal. All right, so let me show you some of these different things. Some of these commands you're going to be familiar with. Some things you're going to have learned in your math classes. Some of them you probably have not learned yet, depending on what grade level you're in. If you're not in, like, say, Algebra 2, you're not in pre-calc, you may not have heard of some of these things. Some you will, but not all. I'm going to introduce them all to you just for the sake of, I want to introduce them to those of you that know what you're talking about, maybe the upperclassmen. So there are built-in constants for pi. Everybody knows what pi is. If I print pi, notice there, pi is a variable. We used that in our last program. We said pi equals 3.14159. But in this case, since we're including it from the library, we're importing it, that's actually a built-in constant. So if I run this, and of course, as always, let me save it. I'll save it as math commands or something like that. When I run this, notice it gives me pi to like 15 decimal places there. It's a very accurate representation of pi. If you've memorized the digits of pi, congratulations, but in this case, it's a built-in thing, so you can just do that. And again, like that is because I imported the math library. If I just, for a moment, just cut that out of there just to try it, like what happens when I try and print pi without the math? It gives me an error saying pi is not defined. So it's telling you that you need this import for that to work. There is also other constants. One that some of you may or may not be familiar with is E. E is the natural base. It's Euler or Euler's constant, depending on however you want to say it. I'm not going to fight about that. But if you print E, E gives you, again, it's known as the natural base, 2.718281828. It's a nice little transcendental number like pi. Again, some of you may have heard of that. Some of you may not have. If you have, hey, there it is. All right, so some of the other, basic commands. How about square root? Print SQRT. And then let's do what's the square root of 2? How about absolute value? Absolute value of -9. Okay, those are nice little math commands. If I try that out, absolute value of -9 is 9, and then the square root of 2, 1.414, and so on and so forth. Notice with these comments, you can put them on their own line, or you can also put the end of the line. You can't, of course, put it at the beginning because as soon as it sees this pound sign, it'll just forget everything else. Like that, this is the square root, and this is the absolute value. There's another one for power. Let's say we have 3 times 4. You can, of course, use that as your exponent symbol. That would be the same thing as saying 3 to the 4th. But you're also able to use the PAL command, PAL 3, 4. And that will do the exact same thing. Why is there a symbol? Why is there a command? There's multiple ways to say that you're happy in English, so why wouldn't there be multiple ways to say something in a programming language? 81 versus 81.0. So you notice there's a subtle difference there. Here you're doing integers. 3 to the 4th power is going to give you 81. PAL is going to give you the decimal form, 81.0. You're probably thinking, what's the big deal about that? For right now, there is no big deal about that. It's not something that you need to worry about. Going into the future, the different variable types, there are a little bit of quirks between the way the computer handles integers and decimals, floating point numbers like we talked about in the last video. So just kind of keep that in mind that there, if you see 0.0, that does mean something subtly different than just a whole number. You may also, again, depending on your level of math, you might know how to do different roots, like the cube root, the 4th root. And you might know that those are done with fraction powers. So, for example, if I said print PAL 2, 0.5, that should give me the same thing as square root of 2, because 2 to the 1/2 power is the square root. And so if you want to do a different root, if you want to do print PAL, let's say 81, 0.25, what's the 4th root of 81? What times what times what times what? The same thing equals 81. 3. 3 times 3 times 3 times 3 equals 81. So again, as I keep saying, depending on your level of math, you may have been exposed to that, maybe, maybe not. 2 to the 1/2 power is the square root of 2. 81 raised to the 1/4 power is the 4th root of 81, which again is 3. I'm exposing all these things. I do not expect you, those of you that you're not at that level yet in math class, when you're not going to be tested or do a program on some of these upper level math commands. So don't worry about it. Again, the purpose of this is to educate you and show those of you that do have the ability to the knowledge to see some of these things. Okay, so we've done square root. We've done some stuff with powers. Let's continue. How about those of you that are in pre-calc? You might know degrees versus radians, and if you're in pre-calc, you probably haven't gotten there yet with unit circle, but you will soon. Print. If I want to convert from degrees to radians, I could say print radians, parenthesis. Again, some of you probably have no idea what this is. When you get to pre-calc, you will learn that there's different ways to measure an angle. Just like if I showed you this pen and I said, how long is the pen? You could say how long it is in centimeters or inches. There's just there are 2 units of measure to measure the same thing. Well, you already, all your life, learned degrees. There's another thing that's called radians. So if I say what would be 90, for example. And I tried that out. It gives me 1.57, which, for those of you that know what you're doing from pre-calculus, 90 degrees is at the top of the unit circle. It would be pi over 2. 3.14 divided by 2 is 1.57. If you don't believe me, you're welcome to try it on your calculator. If you want to go backwards, print degrees, I can't spell, degrees, and remember, pi is a built-in thing, so I could say degrees pi divided by 2. And again, for those of you who know what you're doing, pi divided by 2, top of the circle. Hey, look, those are inverses. They're going to give you the same answer back and forth. 90 degrees is equal to pi over 2 radians. Amazing. Also with pre-calculus and the SOHCAHTOA stuff, sine, opposite, hypotenuse, and all that good stuff, there are sine, cosine, and tangent. You can say, what is the sine of, let's say, 90 degrees? You can say, what is the cosine of 90 degrees? You can say, print, what is the tangent of 90 degrees? And when you try each of those, see how, and again, for those of you that know what you're doing, the sine of 90 should have given you, unit circle professionals, it should give you 1. It gave you that because they're measured in radians. So if I want to convert them to degrees, I could say, put in, what's pi over 2, if I want to do it the long way. Each of those, pi over 2, and there you go. So the sine of pi over 2 sine of 90 is 1.0. You notice here, and you might have seen this come up on your calculator every now and then, that e at the end is like scientific notation. You're saying 6.12 times 10 to the negative 17th, so like 0.00006. That's really 0. The computer is not perfect when it comes to decimals. You have to kind of wrap your head around that. Because these decimals go on forever, your computer's memory does not. So just like your calculator, this is going to give you an approximation. If you look at the tangent, you get 1.6 times 10 to the 16th. That's a gigantic number. Well, that's because it's really infinity. It's trying to tell you that the tangent of 90 degrees is, and again, opposite over adjacent, tangent is the sine over cosine, and so you're saying, what's 1 divided by 0? You can't divide by 0. That's why you're going to get some weird answer like that. If everything I just said is like to you, because you haven't taken pre-calc yet. All right, so let's get back into some of the more mundane, easy things. What about the distance between two things? If I say print dist, let's say 3, 4. Oh, what is that? The int object is not iterable. That's a crazy little command, a crazy little error. What happened there? Happy mistake. Let me just take you on a quick little trip. So all of these math commands, the nice thing about anything programming is all of the answers, for the most part, can be found online, like the help files. So if I just open up a search engine and I just say, I'm going to look up the Python math library. See, there's a link there at the python.org website, and I can click on that. Although some of this is probably going to be kind of strange and foreign to you, but all the commands are here. So if I scroll down, you can look for all these different things, and I want the one that says the distance. Return the Euclidean distance. Euclid, guy who made up geometry, between 2 points P and Q, each given as a sequence or an iterable of coordinates. The 2 points must have the same dimension. What does that mean? That's pretty strange, right? Okay. So what it's getting at is that you're trying to find the distance between 2 points, right? Again, let me just go back here quick. So those aren't 2 points. Those are just two numbers. If I said, what's the distance between 3 and 4, I mean, you're really saying like, what's the distance between 3, 0, 4, 0? You know, it just doesn't jive. It doesn't like the numbers you're giving it. Whenever you have a function, you have to have a valid input, a valid domain. And if it doesn't like that, it's not going to work. You know, go back up top. We did square root. What if we did square root of a negative number? That would be very bad too. So here it's trying to tell us you can't use distance like that. Now, I can change around a little bit. If I said, what is the hypot for hypotenuse? 3, 4. You get 5, because in a 3, 4 right triangle, the hypotenuse is 5. So I can't really show you the distance yet because you haven't learned how to make what needs to go in there. You're only working right now with integers and decimals. So we'll get into points down the road. Again, when you start tinkering with this, you can kind of start pulling on threads. And if you pull on the wrong thread, the whole thing falls apart because you're not really sure, you know, quite yet what's going on. So again, I'm trying to stick with, you know, some of the commands that you'd be familiar with. You're of course familiar with distance, just not how the computer wants you to do it. So we'll get back to that one later. Besides hypotenuse, what else? How about greatest common divisor, GCD? What is the GCD of 24 and 40? What's the biggest number that goes into both 24 and 40? 8. 8's the biggest number that goes into both 24 and 40. How about logarithms? Logarithm, again, for those of you that haven't quite gotten there yet, everything in math has to have an inverse, an opposite. Addition has subtraction, multiplication has division, powers, if I said, like, what's 2 to the third, you could get 8. But if I said 2 to what equals 8, like, how do you undo that? What's the formula? That's where this comes in. It's called a logarithm. And to do the log, you put a parenthesis and then you say the number and then the base. So if I say 2, 8, it gives me 1/3. And again, that final number there, because computers aren't great with decimals, it's going to be off. Like that final decimal is just weird. It's the other ones, like 0.3 repeating, because it's 1/3. You're saying, you know, going back to what I was talking about with powers, you're saying, you know, 8 to the 1/3 would be 2, because the cube root of 8 is 2. Again, if you're not familiar with logs quite yet, that might not make a whole lot of sense, but that's okay. I'm only showing those of you that know what these are. Factorial. Factorials are always fun. Factorial of 10 is going to be 3628800. Reason being, again, let me put a little comment here. Factorial is the one that has the exclamation mark after it. 10 factorial equals 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10. If you do all that up, you get that 3628880 number. Factorial is used for things like your probability problems. If you have 4 people that run a race, how many different ways can they finish? Things like that. Things that are associated with that, combination and permutation. If I say print com, looks like com, but it's combination. If I said, how about 4, 2, and then I did print perm 4, 2, you get 6 and 12. Once again, for those of you that know what that is, this is the 4 choose 2. It's the 4 C2, and I obviously can't write it the way it's supposed to be written in math. And this is 4 P2. It's, if you have 4 things, how many ways can you choose 2 of them where the order doesn't and then does matter. That's the difference between the combination and the permutation. Again, I promise all of you that are looking at this video, at some point in your high school career, all of these things will make sense. The juniors and seniors watching will probably nod their heads and say, yeah, we know all this. If you're a freshman, you probably just haven't been exposed to it yet. But you will. Trust me. The final two that I want to show you are the floor and the ceiling. I go back to what I was talking about with the decimals. There's the greatest integer, the one that chops off the decimals. Well, there's two other commands that are sort of associated. If I say, what is the floor of 3.4, and then I say, what's the ceiling of 3.4? Okay, just picture floor and ceiling. Floor is on the ground, ceiling's on top. So if I have 3.4, it's going to give me, down at the bottom there, you can see 3 and 4. Because 3.4, what is the greatest integer below that? In other words, the floor. So 3.4, it's 3. The ceiling, it's going to go up. So floor down, ceiling up. And as you know, again, those are useful in situations with different roundings and those problems that you probably were the gotcha problems in elementary, middle school. Like your mom sent you to the store and asked you to get enough paint to paint the room. How many cans of paint you get? And the problem works out to be like you need 4.2 cans of paint, and you answer 4.2, and your teacher says like, it can't be. You can't buy 0.2 paint can. You have to buy 5. So in that case, you would say, what's the ceiling of 4.2? And you go up to 5 because it has to be that much and above. So there's lots of different math commands in here. As I said, all the answers as far as like the list of different commands are online. There's more than just this. You're welcome to Google the answer. So at the end here, I want to do a little bit something different. There's going to be an assessment posted on Schoology that's going to require you to input the answer to what I'm about to show you. So for those of you that have finished watching this video, here is what I want you to enter into the assessment in Schoology. You're going to print, let's say, 42 times the square root of 5, and I'm going to get 93.914 blah, 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 blah. Okay, so I'm not going to have you type that in. I'm going to have you type that in. What I'm going to do, you can use these together with each other. So I'm going to take that and give me the floor of that number. So you can stack these commands up, one inside the other. So I have square root inside floor. Just like with functions, there's f of g of x, you're combining functions, function composition. These are all functions you can compose, you can combine. So the answer that I want you to put into the Schoology assessment to get credit for watching this video is 93. Got it? Good. We'll talk more about this throughout the week. You guys have a great day. Thanks a lot.